All right, here we go with the last set of notes on our invertebrates. This one we're going to focus a little bit more on arthropods and some of the behaviors or characteristics associated with this phylum of organisms. One of the main classic attributes of the phylum arthropods is that they molt. Right? All arthropods molt. Basically, what is molting? Well, that's just the periodic shedding of their exoskeleton. We don't want to say it's the shedding of their skin, it's technically their exoskeleton. And why would they do that? Well, basically allows an organism to grow. Think about it as if you were like in the Middle Ages and you got a suit of armor made for you when you were 13. Obviously, that wouldn't work for you when you were 21. You'd have to make a new suit of armor. So they basically have to do the same thing. As they grow, they outgrow their exoskeleton, so they have to make a new one. This, of course, though, would leave them vulnerable for a little while because their new exoskeleton, as they come out of the old one, isn't as hard or isn't as tough, so they're vulnerable to predators. And if they're terrestrial organisms, if they live on land, then they could also be vulnerable to drying out because they don't have that protection from evaporation and things like that. But again, that's something that all arthropods are going to do, this process of molting to get rid of their exoskeleton. Another characteristic that often goes along with that molting is metamorphosis, something you guys are probably familiar with when you think of like butterflies and butterflies changing from caterpillars to butterflies and stuff like that. And so basically it's just a developmental change in form in the most general sense. However, there are two different types of metamorphosis. The first one you're probably less familiar with. This one is called incomplete metamorphosis, and this is just a gradual change. So the immature, or the baby, you could say, looks a lot like the adult. And the grasshopper is something that goes along with this incomplete metamorphosis, where you have the egg, which obviously is very different, and something called the nymph. So basically the baby grasshopper, and eventually is going to go through some molting and turn into an adult, and these guys obviously look basically the same. So that's an incomplete metamorphosis. It's not a complete change in body form. The other option then is just the opposite of incomplete, is complete metamorphosis. Again, something you are more familiar with, where you go through various life stages that are all different from each other. You've got the egg, you've got the larvae, which look like this little worm that lives in the water, and that's eventually going to turn into the adult insect that you know and love, the mosquito. So this one goes through a complete change in developmental form, where the adult looks very, very different from the young. And kind of a cool thing about metamorphosis, and this is probably one of the reasons why arthropods are so successful, is it allows them to fill multiple roles in an ecosystem. If you think of just looking at this mosquito here, it's going to spend part of its life in the water, so it's going to be eating in an aquatic food web and be part of an aquatic food web. So this guy might be a lot of food for fish and things like that, and eating other little things in the water, versus the second half of its life, it's living totally different lifestyle and doing something totally different. Or we think of the good old butterfly, you know, as a caterpillar is more of maybe like a pest to plants and flowers because it's eating them, but then as it becomes an adult, it's more like, hey, oh no, hey butterfly, we want you to come visit us, you drink our tasty nectar and help us pollinate. So good for that reason, allowing the arthropods to do lots of different things in an ecosystem. Next, I want to focus a little bit, maybe some more on their role in insects, in particular role in our ecosystem or in our lives, because a lot of times we think of insects or bugs as strictly bad players, right? Things that we don't like, or pests that we try to get rid of our house and things like that. But they also do have a lot of good aspects and good reasons for being on our planet, and reasons that we actually need them. You know, all the bad things that you think of are, you know, pretty much true. You know, they can be bad because they bug us. To begin with, they can be a nuisance. They can damage our buildings. Think of like termites chewing away a foundation, maybe not a foundation, but the structural support of a house. They can cause or carry disease, like mosquitoes carrying malaria, or locusts destroying crops. And all those things are obviously really, really bad. But they do a lot of good things too. We get a lot of commercial products for them, and they're necessary for our ecosystem as well. Some of the good things, obviously, we've talked about them pollinating flowers and crops, so we would need them. Right? Bees, for example, are huge pollinators, and we actually truck bees all around the country to help us pollinate our crops. They're obviously a vital link in the food chain. Right? If they're munching on grass, like a grasshopper, and then they're getting eaten by something else, they're transferring energy from those primary producers, from the autotrophs up through the heterotrophs. Termites, they damage buildings, but they also play a role in nature eating wood as well, so they might help break down fallen trees or something like that, so helping decompose in the ecosystem. And like I said, we also get a lot of commercial products from insects. Think silk from the silkworm, wax and honey from bees, and lots of other things. So there's definitely a lot of good that come from insects along with the bad. So it's not something that we would want to totally wipe out, even though mosquitoes really bug us, or spiders really creep us out, even though they're not technically not insects. Those are things that we can't really live without. And the final thing I want to talk about for insects is something called mimicry, where you copy something. This is not found exclusively in arthropods at all. You see this in other organisms and other phyla, even other vertebrate phyla as well, but you see it a lot in insects. I think it's pretty cool. There's two different types of mimicry. The first one is called Batesian mimicry, and this is where a non-toxic organism mimics a toxic or a dangerous organism. So the classic example is this over here, where you have the monarch butterfly and the viceroy butterfly. To be honest with you, I'm not really sure which one is which, but the monarch butterfly is kind of toxic to a lot of birds. They don't really eat it. The viceroy is, pretty tasty, I would imagine, if I was a bird. But if you were a bird and you saw these two butterflies and you're like, one of those guys is going to make me sick, I'm not sure which one. You probably wouldn't eat it, right? Which is basically what happens in nature. So the viceroy sort of borrows the protection from that toxic or dangerous organism. So birds have kind of come to figure out, all right, this color shape, this pattern, I'm going to avoid it. And even if it means I might miss out on a tasty meal, that's okay. It's not really worth it. The other type of mimicry is called Mullerian mimicry. This is where two dangerous species mimic each other. So a good example would be these bees, right? A bee in a yellow jacket, or a honeybee and a yellow jacket, whatever. All these, lots of different insects have this yellow and black pattern, right? Yellow stripes, black stripes. Right? You probably know that if you found something yellow and black buzzing around your head, you're probably not going to pick a fight with it, because it might be able to sting you, right? So these guys mimic each other, and that helps reinforce their warning colors. So just like organisms can learn to leave this butterfly alone because it might be gross, even though some are good, most things know that yellow and black is really, really bad, because they kind of learn this lesson over and over and over again, right? Like if I gave you the same set of notes over and over and over again, you'd probably be really bored, but you'd probably learn it a little bit better. So kind of the same idea. So Mullerian, when both of them are dangerous and they copy each other, so they're sort of helping each other out in that respect. And with that, we are all done.